Okay.
I can see the screen.
All right. Well, thank you for the opportunity to present today. My name is Kirstein. I have two roles. I am a faculty member in our Department of Information Technology and Administrative Management, or ITAM, at Central Washington University, and I'm also serving currently as an associate dean in our college. Today, I'm going to talk to you a little bit about some of the ideas I have around integrating common data analytics tools into non-technical undergraduate curricula. And I'll set the stage for this presentation. As we probably are all aware, data is everywhere and it's growing. There's huge amounts of data that are being generated just from transactions or from other sort of common or emerging processes. And this data represents a problem and an opportunity for today's companies. The problem that it represents is that oftentimes there's not people who can actually take advantage of the data. There's not people who are skilled that can mine through the data and work with it and recognize and realize the opportunity that it presents to these companies. And the reason for that is that, well, I'll talk about the reasons for that in a bit, but companies could be missing out on opportunities to benefit from their data or from data that exists out there simply because they lack the people who have the skills to be able to process the data. Traditionally, data analysis has been the domain of those who might be located in areas such as statistics, computer science, math, and increasingly now, universities are offering degrees in data science. And in fact, my home university is offering a program in data science starting this fall. But those are highly trained people. And those highly trained people, while they may have those skills, they're quite often very busy. They're quite often very expensive. They're quite often, have quite a number of priorities. So we don't get their attention when we need it. Plus, there's also not enough of those individuals in the workforce to address the growing data need. And in the US alone, thousands of data jobs go unfulfilled because skilled employees cannot be found. So if we could just identify an opportunity to create more people with data analysis skills, which is foundational skills, we wouldn't have to depend so heavily on the statisticians, the computer scientists, and the data scientists to be the ones who solved our problems for us. So my paper argues that by integrating some fundamental data skills in traditionally non-technical university programs, we can better prepare graduates for the data demands they're likely to face in the workforce. And you can look at some of the more technical disciplines for the undergraduate degrees and even graduate degrees, such like technology and computer science and the like. That's not what I'm referring to. What I'm referring to here are more socially focused, or maybe even business focused, maybe even project management, marketing, those kinds of things. These things that technically have interactions with data, but don't always have people who have the skills to be able to deal with the data. So a second piece of this is by providing graduates with fundamental data skills that will place them in a more competitive position as they seek employment upon graduation. And I'm basing this on experience I've had with both technical and non-technical classes for programs at the undergraduate and graduate level courses, and the interactions I've had with students who are, in a lot of ways, learning these skills for the first time. So let's talk a little bit about what's already happening. Now, if you were to look at business programs around the world, you'll see that a good number of them are already including data analytics. And it comes in different forms. It can be marketing analytics. It can be included with their sort of accounting and finance. But it's really so that their graduates are ready to use those skills to analyze financial, transactional, and strategic information. So some programs are already doing this. But I would argue that other disciplines should follow this example. In many fields, there's going to be large data sets that will be either accumulated or encountered. And a good example is at my home university, we have programs in public health. And there's a great deal of data that is accumulated both locally and nationally that track metrics that have to do with public health concerns. And so a person who's graduating with a degree in public health would benefit greatly by having the ability to sort of work with that data and make some sense out of it. So having employees with data skills is going to allow companies to take advantage of their data without having to wait for, as I alluded to earlier, the very busy and very expensive statisticians, computer scientists, or data scientists. And we really want to bring the skills into the departments. I mean, these are technically departments that aren't really focused on data, but because data is going to become so much more important to what these departments are doing, if we have these skills in the departments, then the departments have better capabilities of being able to process it. So I have proposed a data analysis skill set, and that data analysis skill set actually consists of 3 areas. And I'll go through all three areas in a little bit more detail. First is data discovery, the second is prediction, and the third is segmentation. In data discovery, what we're really doing is we're teaching students how to open a data set and start looking at it to find out what's in it. And I'm currently this quarter teaching a class to 10 graduate students, and I'm finding that there's a varying level of skills that they already have, and some of these skills are brand new to them. So it's really important that we are graduating students that have some of these just fundamental data skills. The first part is visualization. Okay, got muted there for a moment. Can we use tools to actually find out what's in the data set? So that can be done in a number of ways. We can do numeric aggregation summarizations, or we can use visualization tools to just sort of visually display what is in the data set or what is in certain fields of the data.
Kurt.
Yes. Okay. All right. Moving on. We also want to make sure that students have the ability to sort of look at the data and clean the data, right? So when they open the data set, are they identifying any places where data is missing, where fields may be blank or fields may be registering sort of as non-applicable or just, you know, not a number, that kind of thing? How do we deal with that? Because some of our processing later on will trip if it runs into fields where the values is not a number or value is not a number. Are we running into outliers? And also, are some of the fields needing to be reformatted so that in later analysis we can actually process the data set a little better? And then finally, if we're opening a very large data set, oftentimes we don't need it all. And it can become a problem if we are doing processing on the data set later, even in Excel or in some of the open source scripting languages, they can stumble a little bit if the data set is too large. So by removing some of the data set, some of the columns or rows, we can make the processing of the key fields that we want much faster. So the next step that I had was prediction. And really, this is learning from the past. And this is an opportunity for us to go back and look at our past data and the relationships between variables in past data and determine what those relationships were and what they mean for us in the future. So there's kind of 3 areas that students could learn to process data. One is forecasting and time series analysis, and that's a really key sort of skill set in the sense that if we have the ability to look at what's happened in the past and use that to forecast what's likely to happen in the future, this can impact resource needs, it can impact sales, staffing, you know, all many different areas. And then with time series analysis, we can also go on, you know, seasonal trends and ensure that we are coming up with the most accurate forecast that we can use. I would also argue that it's important for students to understand the use of linear regression. And this is really where we're using past relationships between variables to predict numeric values in the future. So we can use one predictor or multiple predictors to help us build a model that we can then apply to new data where we don't know the outcomes. And what that model will do is that model will help us predict those outcomes. And a good way to use that, or a good example of using that, would be if we are trying to establish pricing for, say, cars or some other high-level commodity. We can look at what those products sold for in the past and use that to build the model so that we can price it out in the future so we maximize our return. I would also argue that I think it's important for students to learn and understand logistic regression. And this, very similar to linear regression, allows us, instead of predicting an outcome value, it allows us to predict an outcome likelihood. And if students understand that they can use one variable or multiple variables and put it into a logistic regression or create a logistic regression model, then we have the ability to sort of predict the likelihood of an event occurring. And this is something that they could do when they are identifying customers who are likely to repeat or customers who are likely to become good credit risks. Lastly, I'll talk a little bit about data segmentation. Data segmentation is where we can take our data set and we can divide it up into smaller sections so that we can specifically process those customers or those events or whatever we can specifically process those. Couple tools that students can learn how to do here. Cluster analysis, and two types of cluster analysis that I propose. One is k-means, which is where we divide a large data set into some number of groups. We decide what that number is and we set that value. That's what k becomes. So we use a Euclidean distance or some other mechanism to be able to sort of determine the closeness of data points to particular midpoints. And that allows us to divide the data into small groups. And those small groups have commonality amongst each other on certain fields that we've selected. We can also use a hierarchical or agglomerative clustering mechanism where we start out with each record being its own cluster, and then we do a repeated pattern of joining the two that are the most similar. And we continue until all records are accounted for. What that allows us to do is we plot that on a dendrogram, and it tells us how similar the nodes are and how much similarity there is, but it also allows us to divide the data into logical groups. And we don't need to know what those groups are. We don't need to know what that number is because this particular mechanism will show us how to do that. Once we have groups identified, for example, we go back into past data and we identify maybe 2, 3, or 4 different groups of customers. Then if we get 1,000 new customers and we want to know, okay, how do we market to these customers? How do we understand who they are, what their buying patterns are? We can use a tool called classification. And essentially, classification allows us to take a look at each new customer, compare it to the members of the other groups, and determine which group it fits in. And this could become a very useful tool when we are trying to, maybe it's 1,000 or maybe it's 10,000 customers, we are trying to determine what is the best mechanism or best process for marketing to those customers so that they feel like they've had a personal experience. And lastly, association rules allows us to look at past transactions or past events and determine the likelihood that products are sold together or events occur together. And we can take advantage of instances where we have a high level of confidence in an association. So just to finish up, most of these tools are really widely available. And Microsoft Excel with the data analysis add-on package provides many of these tools. Data discovery, visualization, cleaning, and reduction are all available in the standard version. Forecasting and linear regression, forecasting is actually available in the standard version past 2016, but linear regression is part of the add-on. And then there's some rudimentary segmentation available using filters. But for those tools that aren't covered by Microsoft Excel, there are open source scripting languages such as R and Python, and it's fairly easy to set up models using, or to create models for logistic regression and also to set up cluster analysis and classification. Also, if students have access to SPSS, which can sometimes be a little expensive, or JASP, which is an open source and free tool, these contain many of these functions as well. So to summarize, infusing these skills into non-technical university curricula will position graduates with skills that they will need in the data-driven economy. These skills are useful and accessible. Universities need to plan curriculum that addresses these skills, and companies can expand their use of data without requiring more individuals with senior level statistical or computer science skills. Okay, I'll entertain any questions.